Okay, I got it going. It's only running on one motor coil position. And it's going 630 RPM. It's drawing 140 milliamps. See it here. And I have a little power supply and a couple capacitors. I don't have any batteries here. So it's drawing 14 volts while it was running. 14.8. Okay. Now, get this out of the way. This is voltage across a capacitor. It's a 100 UF capacitor. It's over here. 63 volt is all. And here's that diode. Very, very fast diode. And it's capturing the back EMF spike, the recoil, the flyback from the pulsing MOSFET. So I'm going to show you how much voltage it collects in a short amount of time. As soon as I connect this to the wire, it should start filling up. And this is the capacitor filling up we're looking at right here. Try to get so you can see it good. Okay, ready? 1, 2, 3. Oh. Got a problem here. Oh, I don't have the ground hooked up to the meter. Ooh, shoot, it's 90 volts. Okay, hold it. Okay, I just disconnected it, went to 36. Now I'm going to short that capacitor out. Now hear that? A little pop. And do it again. Okay, capacitor's at 0, even though the meter says 36, but I'm going to hook up this meter again. Anyways, okay, we're going to, it's weird, the meter says 20 volts and there's only the ground of the meter's hooked up. But anyways, let's just show this. There. Just hooked it up. 80 volts already. Whoa. Might blow the capacitor because it's only rated for 63. There. Hear that? Okay, now I want to demonstrate. Forget about these numbers, but you see how fast the capacitor fills up. I want to demonstrate something here. It's like, let's say you put a load on this capacitor while it's filling. And so I'm going to just short it. Hear that? Kills the motor. Okay? Really kills it. Okay, but now watch this. I fill up the capacitor. It's called a two-stage output circuit. I fill up this capacitor now. Here it goes. Look at that, it's at 0 now. Okay, the capacitor's up to 90 already. Now, I disconnect the capacitor from the diode that's filling it. And now I short it out. And let's pretend like this short is a load. It doesn't do anything affecting the motor wise. I'm going to do it again. Okay, here it is. Fill it up. I'm filling up the capacitor now from that diode. Let's get it up. Let's get it up to there. Now I short it out. Hear it? And it didn't affect the motor because it's disconnected when it discharges. So you fill it up all by itself. Don't have a load on the capacitor. Fill it up all by itself. And then have a circuit that discharges it to the load while it's disconnected from that diode. Do it again. Here we're up to 91 volts. And I've disconnected it now. It's not connected to the diode. And now I short it out. Nothing happened to the motor. Okay, so I just wanted to show that. That's the proper way when you do collect back EMF, recoil, flyback spike into capacitors. You have to have a circuit that disconnects that capacitor from the diode or the circuit when it discharges. Okay, so there's that. So it's still running on 140 amps. I mean 0.14 amps. And 15 volts. 14.4. Okay, I'm gonna slow it down. Turn it off. Okay, in my last video, you couldn't even see this stuff. So I'm going to do it again and hold it still so the camera can focus. Okay, diode HFA25PB60, MOSFET G4076V5, Hall effect A1120LUA-T. Generator coils 180 ohms, motor coils 12 ohms, pickup coils 37 ohms. Those are approximate because they aren't all the same. And the cores in the motor coils are 5 by 35 millimeters, and the generator coils are about 19 millimeters long and also 5 millimeters. And there's that picture again of the shape of the generator coil cores. Okay. Here's the flyback spike catching diode, and there's the chip, and there's the MOSFET. And from it, I have this Hall effect coming off, and there's a 22K resistor from this one, which is the signal. The green here and this kind of the signal that comes off the diode to the positive. So, and the middle one's the ground. I mean, of the Hall effect. The Hall effect, the green is the signal, the red is the positive, and the black is the ground of the Hall effect. There's 3 leads on the Hall effect. And across from the green to the red goes a 22K resistor. Just thought I'd tell you that. Here's the back of it. So this is a little MOSFET module that's running it. So there it is. Next time I'm going to show the generator coils. And also the pickup lines, kind of like how it makes power as it runs. I showed you the power from the backemf spike. So it's interesting, the pickup coils behind the motor coil, they also pick up that spike as well. Like there's this diode here, you saw the capacitor fill up to 90 volts quick. The pickup coils also do the same thing. You can use a single diode and fill up a capacitor, and it just keeps filling up and up and up because the spike is coming through those two. So, and this is for the reflective, to check the RPMs. So there it is running. Okay, thanks a lot. Get back to you later.